Hello guys, this is the integration by parts method. So before we start explaining what is integration by parts, I want to tell you that we usually use integration by parts when we have the integral of a product and you cannot use a substitution rule. So if you make u one of the two, the du is not the other part of the integral. Before we start, we have to think about these two integrals. Just for you to be sure, the integral of x times dx, which is equals to x squared over 2 plus c, and the integral of x squared times dx, which is equals to x cubed over 3 plus c. So as you can see, the integral of the product of x times x squared times dx, it's not the same as the integral of x times dx times the integral of x squared times dx, because that will be the integral of x cubed times dx, and that is completely different to the product of the two integrals. If we multiply x squared over 2 times x cubed over 3 plus c, the result is completely different than the original integrand. So as you can see, the integral of a product is different to the product of the integrals. The integration by parts formula comes from the product rule from the differentiation formulas. So the derivative of a product, as you can see in this formula, it is the first function times the derivative of the second plus the second function times the derivative of the first. So let's rewrite this as the differentiation formula. The differential of u times b, it is equals to the u times the differential of b plus b times the differential of u. And it is basically the same as but we are taking into account, instead of f and g, u and b as functions. And I'm using those because these are part of the integration by parts formula. So when you integrate both sides of the formula, you have that the integral of the differential of ub equals to the integral of u times dv plus the integral of v times du. Then you obtain that, as you can know, as the differential and the integral are opposite formulas or opposite operations, you have that u times b equals to the integral of u times dv plus the integral of b times du. And the only thing that is missing in this formula is that we want to solve for this term. So we will have the integral of u times dv, it is equals to u times b minus the integral of b times du. And this, guys, is the formula for integration by parts, or the integration by parts formula. And you are probably thinking about what a difficult formula to learn, the integral of u times dv equals to u times b minus the integral of b times du, but I will help you a lot using an image. Oh yes, believe it or not, this image will be very, very useful for you guys. What is that? And I'm going to change to Spanish because the mnemotechnic resource is in Spanish. Entonces, como habíamos dicho, la fórmula de integración por partes es u times dv equals to u times b minus the integral b times du. Entonces lo que los va a hacer acordar son los siguientes letras. Un día vi una vaca vestida de uniforme. Entonces todo lo que tienen que acordarse es de esta imagen para recordar la fórmula de integration by parts. Okay, once you know the formula, you have to copy it to your index card, please. Index card, very important. Try to memorize it. I'm plenty sure that you are going to be able to do that. And now let's do a simple example. Okay, Let me explain very, very fast how is that we cannot use substitution rule for this integral. We have the integral of x times sine of x. If you use u as x, the derivative of u will be dx, and we don't get the second part of the integral, which is sine. And what happens if we use u as sine of x? The derivative of sine of x, it is cosine of x times dx, and we don't get cosine of x because the other part is just x. So we have to use integration by parts, which is a double change of variable. In this case, you have to use u and you have to use dv. One of the parts of the integral is going to be u and the other part will be dv. And a very important hint is that u is always the simplest function in the product. So in this case, u is going to be x and dv is going to be sine of x. And once you have u and dv, the other thing that you have to obtain is du, which is dx, and b, which is the integral. Dv is always with the dx at the end because it is a differential. So b is going to be the integral of sine of x times dx, which is negative cosine of x times dx. So now that we have u, dv, du, and v, let's use the formula. The formula says that the integral of u times dv, it is equals to u, una, times b, vaca, minus the integral of b times du, which is dx. And I'm sorry if I didn't have enough space, but I will write only the right side of the equation, that is negative x cosine of x minus the integral of cosine. I'm writing the constant negative 1 out of the integral sign, and finally the integral of cosine, which is sine of x plus c. So this is your indefinite integral using the by parts formula, but let's verify it. Okay, so let's do the verifying. The formula is this, so the differential of the function with respect of x is, first you have a product, okay, this is f, this is g, so I'm going to obtain the derivative of a product, which is the first function, times the derivative of the second, the derivative of cosine, which is negative sine of x, plus the derivative of f of x, which is negative 1, times the second, which is cosine, plus the derivative of sine, which is cosine of x plus 0, because the derivative of a constant is 0. So what do we have? We have dy, it is equals to negative x times negative sine, x times sine of x, minus cosine of x plus cosine of x plus 0. So we simplify the factors and we obtain that dy equals to x sine of x times dx. And that's how you can know that your integral was correct. Okay, this second exercise, it's again integration by parts integral, because we have the factor x, which the derivative is dx, and we have the factor 4x plus 5 in square root, or the square root of 4x plus 5, which the derivative will be 1/2 of 4x plus 5 to the negative 1/2, so you cannot use substitution rule. Again, we have to use u and du. So as I have told you, u is going to be my simplest factor, so in this case u is going to be x, and dv is going to be the other factor, which is the square root of 4x plus 5 times dx. So the u is very simple, the u is dx, and v is going to be the integral of 4x plus 5 to the 1/2 times dx. To do this integral, we have to make u equals to 4x plus 5, so the u equals to 4 times the x, so the u over 4 will be the x. And the integral will be the integral of u to the 1/2 times the u over 4. So we're still looking for b. b is equals to 1/4 times u to the 3/2 over 3/2 plus c. So b will be equals to 1 over, it will be 2/12 or 1 over 6 square root of 4x plus 5 cubed plus c. And the constant in this case is not so important because we're going to substitute the constant at the end. So let me rewrite the function in terms of u and dv. That will be ux times v 1/6 of square root of 4x plus 5 to the 3, okay, u times b minus the integral of b 1/6. I'm going to write 4x plus 5 to the 3/2 times the u, which is the x. I have copied the formula of u times b u times b minus the v times u times b minus v times the u. This is, let's do the product. This is 1/6 of x times the square root of 4x plus 5 cubed. And then we have to write the constant out of the integral sign, and that will be u to the 3/2 times the u over 4. So this will be 1/6 of x times the integral, the square root, the square root of 4x plus 5 cubed minus 1 over 24, constant out of the integral sign, u to the 5/3 over 5/3 plus c. You add the c at the end because it is the final constant, the arbitrary constant that we will never ever know, and that is 3 over 24. It will be 1 over 8, so it will be 1 over 40 u, which is 4x plus 5, again to the 5/3, could be, which be the cubic root of 4x plus 5 to the 5 plus a constant. And I'm sorry for this is a cubic root. And that will be your y. Y it is equals to 1/6 of x times the square root of 4x plus 5 cubed minus 1 over 40 times the cubic root of 4x plus 5 to the 5 plus c. And you could do this verifying. I'm not going to do it, but I will ask you to continue with the exercises that you have on your notes. And the good news is that if you give me the verifying of this integral and the integral is correct, I will give you an extra point on the last quiz. Okay? Well, see you. I hope you have find this useful. I see you in class.